Hello, ladies and gentlemen. We're going to continue on with an example of the mean value theorem, which says, determine if the mean value theorem can be applied. Then determine the value or values of C guaranteed by the mean value theorem. In this case, our function is f of x equals x times x squared minus x minus 2 on the closed interval from negative 1 to 1. This is actually out of our Larson book. In order to determine, first of all, if the mean value theorem can be applied, we're going to take a look at the graph of the function to see if it is continuous and differentiable. Here is the graph of our function. There are no sharp turns and there are no jumps. So therefore we're going to say this function is continuous and differentiable, and the mean value theorem must apply. So what we're looking for in the mean value theorem is we're looking for a point on this graph where the slope of the secant line equals the slope of the tangent line. Now what we're looking at here is a graph from -3 all the way to +3, and our interval is only from -1 to +1. So make sure you're only focusing on this area of the graph, from here, -1, all the way to here, +1. I'm going to include here a secant line connecting those two x values. That green line is the secant line from -1 to +1. And now I want you to take a guess. Where would you say, if I were to follow this function and imagine its tangent lines, where on this graph does the slope of the tangent line equal the slope of the secant line? So take a look, follow it along, imagine there's tangent lines there. Where on this graph do you think the slope of the secant line equals the slope of the tangent line? Before I move on, I'd like for you to take a guess. So take a look carefully, imagine these tangent lines, tangent line here, and follow it along. At what x value does it look like the tangent line will equal the slope of the secant line? In order for us to calculate this analytically, we first need the slope of the secant line. So we have our function x times x squared minus x minus 2, and we're going to find the slope of the secant line on the interval from -1 to 1 by just using our old slope formula y2 minus y1 over x2 minus x1, or in calculus f of b minus f of a all over b minus a. That'll look like this. F of 1 minus f of -1 divided by 1 minus -1. Plugging in 1 into the function gives us an output of -2. Plugging in a 0 into the function, plugging in a -1 into the function gives us a 0 as an output value, all divided by 1 minus -1, which is 2. Working that out, -2 divided by 2 equals -1. That -1 represents the slope of our secant line, which was the green line up here in our picture. So we're looking for a point where the slope of the tangent line equals -1, the slope of the secant line that we just calculated. Now, it should be drilled into you by now that in calculus, when you hear the word slope of the tangent line, you're automatically thinking derivatives. So we're going to go back to our original function and get it ready to take a derivative. To do so, simple enough, we distribute the x, and it makes the derivative much, much easier. The derivative of x cubed minus x squared minus 2x is 3x squared minus 2x minus 2. And our goal is to find at what x value does the slope of the tangent line equal the slope of the secant line. Well, just a minute ago, we found the slope of the secant line. It was -1. So we're going to take our derivative and make it equal to -1. So -1 is equal to 3x squared minus 2x minus 2. And now this follows the structure of the conclusion of the mean value theorem, which is that we're looking for a point C where f of b minus f of a all over b minus a, which was -1, equals the derivative at C. So we've already plugged in -1 for our slope of our secant line. I'm going to add 1 to both sides, and that leaves me with 0 equals 3x squared minus 2x minus 1. Since it's a quadratic equation, we have two choices to solve this. We could either factor or use the quadratic formula. Well, in this case, factoring works out very nicely. 3x plus 1 times x minus 1. And solving each factor, setting it equal to 0. And solving for x, we end up with x equal to -1/3 and x equal to 1. Since 1 is on our endpoint, we're only looking for c values in between -1 and 1, where the mean value theorem works, so we're only going to focus on at x equals -1/3. Now, think back to your guess. Did you guess negative 1/3 or negative 0.3, negative 0.4, negative 0.2? Hopefully you were in that area. And if you did, congratulations. You came pretty close to figuring out the C value just graphically. Now this value of C is at this input value, that is the point where the slope of the secant line equals the slope of the tangent line. M for slope, slope of the secant equals slope of the tangent line. At this x value, C equals negative 1/3. So if we were to look back to our graph at C equals negative 1/3 was approximately right there. At this point, that's the point you should have guessed. That point is where you should have guessed. So I should be able to produce a tangent line right at negative 1/3. Give me 1 second. Got to type in my x value here. Negative 1/3. And sure enough, right at negative 1/3, the slope of the tangent line is equal to the slope of the secant line. And you notice that because the two lines are parallel. All right, that takes us through an example of the mean value theorem. Hope you guys understood it. That's it.